So now I just want you to drive you through an example for the variational form. So imagine we have a 2-qubit system. So remember our expression for the variational form allow us to go from an entropy problem to a distant geometrical problem, optimization problem, where we see that the best states we can have is a real state rho b and not a tricked state to be accurate. So let's take have states rho a b being equal to over 2 0 0 0 0 plus 1 over 2 1 1. If we calculate like the entropy or eigenvalues as 1 over 2 over 2, so h of rho b just minus 1 of over 2 of log 1 over 2 plus 1 over 2 log 1 over 2, which is like minus 1 over 2 minus 1 over 2, which is equal to minus, which is equal to 1 minus 1, which is equal to 1. So if we check about the states rho b, and here, for example, then just a trace of a of rho b, and so we just eliminate this, trace out a, so just 1 over 2 0 0 plus 1 over 2 f 1 1, which is just 1 over 2 1 over 2 0 0. So the entropy of rho b, it just have both time the same stuff, 1 over 2 time, which is equal to 1, as we saw before. And so the entropy that we need it here. So we have all the elements, just h of a minus b, just like h for ab minus h for b, which is in our case 1 minus 1, which is 0, because we find it like here and here. So if we want to calculate like the best choice, so tb for ab in our case, because it's in as a distance, can directly see that let's calculate like this first term, which is like last year for AB, knowing AI or B, it just like we can like calculate for just like the minor trace for AB for AB plus for AB log AI 0 for B. For applied to this the distribution, because I already said it in another video. And so yeah, we'll just have this. just need to calculate it. So this, you just need to know like array B, like array B, how many it does, and array B log AI array B, how many it does. So basically trace of array B, just like just like this, it's just one, and for array B like uh, let's just calculate log of array B and of A array B. So log of array B, now you have first step, so you have 1/2 here, 1/2 and 0 here. So minus so log array B just -1, but so just -1 multiplied, so just -1 because you sum that bigger. So you just end up with trace of array B like like -1, and so just -1, which is equal to 1. And log I row B is basically the same, and like you have -1 every one, so you have whenever 2 here, and whenever 2 off, but and so you have -1 every line, but we have only one time -1, and so it will just give you -1, and so it will be equal to 0. And um, yeah, that's so that's our step, and suppose that our conditional entropy will be equal to 0, and because like anyway for section 8, like the infinitum Ruby, because other hypothesis will always add certainty to Ruby, for example, Ruby and TV, and so distance equals 0. But if we take, like, for example, another example with TV equals like with t equal, for example, 0, 0, and to have local which take like 1 minus epsilon, 0, 0, epsilon, with epsilon 0. Relate like AX or TB to equal to 1 minus epsilon, epsilon, 1 minus epsilon, epsilon, is 0 everywhere. So yeah. So if you calculate to this, just like trace of AB of log of 2 ix of tb, as in the definition. So clearly we take our stuff, so if I wanted to write correctly, so AI will be this, and so it's a 0, 1 minus epsilon 0, 0 epsilon, which is, and so just, as earlier, just take the first step by step, we take the log of 2 of AI of TV, and so it just log of 2 of 1 minus epsilon, so yeah, 1 minus epsilon, log epsilon, 1 minus epsilon, log epsilon, with 0 everywhere else, and so if you apply multiplication for AB, or log of AI over TV, brings that row AB, it's like, as a real state with 1 over 2, 1 over 2, multiplied by this, log of 1 over epsilon, log of epsilon, log of 1 minus epsilon, log of epsilon, just equal to 1 over 2 of log minus epsilon of 1 over 2 of log epsilon. So if you trace about it, trace of AB of log of AI or TB is equal to 1 over 2 of 1 minus epsilon multiplied by 2, so just at the end plus 1 over 2 log of epsilon, and so when we take like limit of epsilon to 0, like it just keep log of 1, so that's equal to 0, and this will give us minus infinity, and so our trace is just going into minus infinity. And we have that we want to calculate it like this, which is just trace of AB minus trace of AB minus the trace of AB log AB plus the trace of AB log AI or TB, and so like it just 0 uh, minus infinity. And so yeah, it diverges completely. What it says is like by using like tb equals 0, we affirm that Bob, like we need to affirm in our system like Alice and Bob have the same stuff, 0, 1, 1, 1, 1, always the same. So by affirming that Bob has always 0 and can never have 1, 1, so never like that Bob, like in this case, which is second way, will always have 0 and never 1. We just say something that is totally wrong, because normally the real state rate will be produce one at least 50% of the time. So if we did guess that it will have a 1, then the spontaneity of information isn't. So in our formula, uh, with a good choice t big L, then there is no problem, like the quantity of the penalty of is 0, like we have literally what we want, but with one choice it goes to minus infinity, where that shows that tb is the worst possible the possible choice, like yeah, we are innate option to choose tb equal Robin instead of tb equal 0, 0, which is by the way the only option maximize also, so it's real boundary which is 0. So yeah, thanks for listening.